Okay, we need to learn the rules for multiplying monomials. Monomials, that just means one term. So let's begin. If I had a squared times a to the third. If you multiply the same base, these are both a's, the same base, you will get that base and you add their exponents. 2 plus 3, your answer is going to be a to the fifth. If you want to understand that a little bit more, a squared, do you believe that is a times a? A to the third, that is a times a times a. So that's actually a to the fifth. But I don't have time to write all these a's down, so I would rather learn my rules. Okay, another rule. If I am dividing the same base, if I have a to the seventh divided by a to the fifth, if I am dividing the same base, I will take that base, write it down, and it is the top exponent, the exponent of the numerator, minus the bottom exponent, the exponent in the denominator, and that will be a to the second. I write the base down, and I would take the exponent in the numerator minus the exponent in the denominator, and I will get 2. Once again, if you want a little clarification, a to the seventh, a to the fifth, and then, of course, I would cancel. Those a's would cancel. Those a's. And if you notice, I have a squared left in the numerator. A power to a power, or an exponent. So I have this power or exponent, same, it means the same thing, and it's raised to another power. When you have a power raised to a power, you are supposed to multiply them. Well, so a squared to the fifth would be a to the 2 times 5, which will be a to the 10th. Once again, I like to prove to you that this math is not all made up. So a squared to the fifth, that means a squared times a squared times a squared times a squared, and one more to go, times a squared. Well, a squared is a times a. I'm still working on this. And in the end, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same answer I got when I learned my rules. There's one more rule I want to show you. We're dividing the same base again, so we've already done one like these. You know that I take that base, the a, and it is the top exponent, the exponent in the numerator, minus the bottom. That'd be a to the negative 3. Well, you know how in elementary school we like you to reduce things? We don't like negative exponents. In order to simplify that all the way, if I have a negative exponent, I will move it. It's in the numerator. I'm moving it to the denominator. And that changes the signs of the exponent. The answer is 1 over a to the third. But do you believe that a to the fifth means that divided by a to the eighth is that? Then when I do a little bit of canceling, I'll just have 1 left in the numerator and a to the third in the denominator. Same answer. You can look at that problem and know that our a's are going to be left in the denominator. But we do need to know our rules because sometimes there are not problems that are this simple. So let's go over our rules real quickly. If I am multiplying the same base, let's just put a up here to make it fun. When I am multiplying the same base, I take that base, and what do I do to those exponents? I add them. Whatever they are, I will add them. If I am dividing the same base, let's say I have x to the a divided by x to the t. That's going to equal x, I will put it in the numerator, the top exponent, the exponent from the numerator, minus the exponent in the denominator. Okay, and two more rules. If I have a power that's raised to another power, I multiply them. And if you ever end up with a negative exponent, then how do you simplify that? It'd be 1 over, and in this case, x to the positive a. Let's try to do a couple of problems. Okay, I'm not changing the rules for these coefficients, these regular numbers. Remember, the rules I have learned are dealing with monomials and exponents. I just reduced these just like I did in 3rd grade. 3 will go into 27 9 times, and 3 will go into 15 5 times. So that will be 9 over 5. Now I'm going to go strictly by my rules with the variables. I have a in the numerator and the denominator, the same base. So I'm going to take the 4 minus the 3. Now I only have a b in the numerator. I do not have a b in the denominator. So I will just leave it where it is and not do anything to it. I have a c in the numerator and the denominator. I will take 9 minus 15. I know you might have gone a different route with that. That's okay. So I have 9 over 5. A to the 4 minus 3, that would be a to the first. I'm not going to put 1. B to the 6th is just b to the 6th. And that would be c. 9 minus 15 is a negative 6. Am I done? No. This c to the negative 6, I need to move that to the denominator. So that'd be c to the 6. And now I am done. Let's work one more problem. Let's reduce our coefficients first. Now once again, this negative, I don't change the rules for my coefficients. 22 divided by negative 11 is a negative 2. That is in the numerator. 11 will go into that, 11 will go into that. Now let's work with our variables. I will have a to the, be 2 minus 1. So even though there's not an exponent there, I should know it's 1. B to the 5 minus 1. And C, in the beginning, I put everything in the numerator and then I adjust, unless I have a coefficient that I reduced here. So be C to the 7 minus 2. So I have negative 2, A to the first, B to the 4th, C to the 5th. Do I need to move anything? Well, all of my exponents are positive. I'm fine. Now, you may look at this negative 2. Well, this is not an exponent. This is just a regular number, a 2. We can have a negative 2. It's okay.